Okay, in this video I'm going to go through some harder examples of the chain rule, a few more chain rule examples. And because in the first couple of videos they were very basic examples, I didn't use any of the sine, cos or e to the power x functions and things like that. So, and if you haven't already watched the videos on differentiating the trigonometric functions, the things like sine squared x and also the exponential, logarithms and all that, then watch all of them first before trying to go through this video. So I'll start with something that's relatively easy. So let's start with something like y equals, let's say, sine cube of 2x minus 1. And let's say I want to define dy over dx. And I'll start by doing this in the sort of using the shortcut where we do it just in one step. And maybe I'll probably also go through in more detail once I've first done it. Okay, now sine cube 2x minus 1. So dy over dx. So remember, this is not a product of any two functions. It's all one function. It's sort of a composite function. This is a composite function. I have sine of 2x minus 1 and all that raised to the third power. And just another way to write this is the same as putting a bracket around there and then raising it to a power of 3. And now what we said was if we have sine x to the power n, if we have sine x to the power n, then I can bring the power to the front, reduce the power by 1, and then multiply by the derivative of what's inside. So in this case, my power is equal to 3, so I bring that up front. So I have 3 times, I leave whatever is inside just as it is, so I have sine of 2x minus 1. I reduce the power by 1. So you can think of that as the term n times x to the power n minus 1. But then I got to multiply that by the derivative of the inside part, the derivative of all of that. Now the derivative of sine 2x minus 1, the derivative of sine is cos. So I get cos 2x minus 1. So the derivative of sine x is cos x. So sine of some function, the derivative of sine of some function will be the cos of that function. But I got to multiply that again by whatever that function is. So I'll put a bracket around here and the derivative of this part. So I got to do the derivative of that part now. So the derivative of 2x minus 1 will be equal to 2. So I could rewrite this as 6 times sine squared 2x minus 1 times cos 2x minus 1. And this one, I usually like to think of this as an outside-inside rule. So I first look at the outermost part, which is the power 3. So I bring the 3 to the front, leave the inside part as it is, reduce the power by 1. Then I sort of go to the next step. So what's inside? So inside is the sine 2x minus 1. And so the derivative of the sine 2x minus 1, that's cos 2x minus 1. And then I got to differentiate what's inside that as well. But if you didn't fully understand how I got this, I'll go through this in more detail. And let's do that by let's first find what's the derivative of sine 2x minus 1 is. So this is the final answer for this question, but just to go through in more detail, what we'll do is let's see what's the derivative of sine 2x minus 1. Let's say if I want to use the chain rule in more detail. And from the previous videos on trigonometric functions, what we said was if I have sine of some function, then choose that function as your new variable. So in this case, I might say let t equals 2x minus 1, in which case y will be equal to sine of t. So here dt over dx will be equal to 2, and dy over dt will be equal to cos t. And then using the chain rule, we got dy over dx equals dy over dt times dt over dx. And you should probably know this chain rule by now if you watch the first couple of videos on the chain rule. Now dy over dt, that is equal to cos t. That's equal to cos t times dt over dx. dt over dx is equal to 2, so I'll put the 2 up front here. And t is equal to 2x minus 1. So this is the same as 2 times cos 2x minus 1. Okay, now what we've established is that the derivative of sine 2x minus 1 is equal to 2 cos 2x minus 1. And you can see if I use the shortcut method, the derivative of sine is equal to cos, so I get cos 2x minus 1, and I got to multiply it by the derivative of what's inside. Okay, but the initial function I wanted to differentiate was this one, all that raised to the power of 3. So let's do that now. So let's take y equals sine 2x minus 1 sine 2x minus 1, and that raised to the power of 3. And also from the previous trigonometric videos, I said if you have a trigonometric function raised to a power, or any function raised to a power, then take that function as your t substitution. So take t equals, let's say, sine 2x minus 1, which means y would be equal to t cubed. Then dt over dx. Now we've already seen that the derivative of sine 2x minus 1, I've showed that's equal to 2 cos 2x minus 1. So I'll write that down, 2 cos 2x minus 1, and dy over dt will be equal to 3t squared. And if I use the chain rule again, if I say, so dy over dx is equal to dy over dt, which in this case is 3t squared, times dt over dx. dt over dx is 2 cos, that will be equal to 2 cos 2x minus 1. And then I got to make a substitution back for t. So my t substitution was to say sine 2x minus 1. So I have 3 times sine 2x minus 1. And this is t squared. So I have sine 2x minus 1 whole thing squared times 2 cos 2x minus 1. I can multiply the 2 and 3 together to give 6 sine squared 2x minus 1 times cos 2x minus 1. Okay, and of course the answers would be the same. So I get 6 sine squared 2x minus 1 cos 2x minus 1, which is the same as what I got previously. And you can think of this as being the entire working. So you can think of this as the more detailed working, but really if you're very good at using the chain rule and differentiation, you should be able to do this sort of thing in one step.